You're probably like, all right, I can do this, no problem. But just as a reminder, when we add or subtract fractions, you need to have a common denominator. If it is not common, you need to find a common denominator. In this case, it would be 36. Okay? Once we find the denominator, so it's just the concept we're thinking of here, since we changed the denominator, we have to change the numerator. To get from 4 to 36, I multiply by 9, so I do the same thing in the numerator, and I would get 18. Over here, to get from 9 to 30, what?
27.
Oh my God, what did I even just do? Thank you. I don't know. For some reason, I had 3 times 6 in my head. Okay. Thank you. I'm not that off my game today, but that's okay. This one I multiply by 4, just yell out at me if I do things wrong. That would be 20. It's exact problem, that's great. And remember, you keep the common denominator. Now that it's common, you don't change it. You add the numerators. I can't reduce that. I'm done. So that's the concept we're going to do, except for now we're going to do it with polynomials. So that's why it gets a little bit more complicated as we go. But if you can really just like keep the basics in the back of your head, it should hopefully make sense. So that was your warm up. Now let's kind of start in on some of those problems. So number 1, we're adding 2 fractions, 2 rationals. But we have some binomials mixed in there, so that makes it a little bit more exciting. So let me show you kind of how to go about doing these. You need to think about simplifying as well. So even after we've added, is there anything else that we can do to simplify these? So the nice thing about this is we have a common denominator, delightful. So whatever the common denominator is going to stay as a common denominator in my answer. Okay, so that concept hopefully makes sense. Since we're not changing the denominators, we can just add the numerators. And when I add, I'm just combining, I'm just combining like terms. So I go through and I'm going to do 2x plus x. That's going to give me 3x. And then I have this 5, and I'm going to add that to 1, and I get 6. So we've combined as much as we can. But what happens is when we talk about simplifying from like our last section, we still want to do that. So these are both factorable, right? They both have GCFs. So I'm going to take out the GCF. So the steps that we were doing before are still valid. And then I just see, if you can't do anything from there, that's fine. You just leave that as your answer. But I notice that I do have a common factor of x plus 2. So my final answer would just be 3/5. You do still have to do domain restrictions, since there is a variable in the denominator. We would say x cannot equal, I always go to the factor form because it's already kind of taken care of for me, and x could not equal -2, just as my restriction. So common denominators are our friends. If it's there, you're feeling good because you're just doing your best to combine as much as you can. But then once again, once you've combined, go to the like kind of factoring. Does anything else cancel? All those steps. All right, so let me show you 2, and I'm going to have you guys try 3. So number 2. Let me write it. So there's just one thing with subtraction, and it's just when people know how to subtract. Once again, you guys know how to add, you know how to subtract, all that stuff. It's just the little mistakes I like to point out to you, so just hopefully you don't make them in the future. So the first thing I notice, common denominator. So I'm feeling pretty good about that. I'm going to make a new fraction with that denominator. I'm going to combine my numerators using subtraction. The big thing here is we are subtracting both of these terms. So just make sure that minus doesn't go with the a, it goes with the 8 as well. So sometimes I even like distribute it in and I do -a minus 8. Just to remind myself, I'm a test go with both. So now I can combine 7a minus a will give me 6a. -10 minus 8 will give me -18. Or you can just do, you subtract, just make sure you do it to both. Okay, so we've combined as much as we can. We did the subtracting part, but we still need to simplify. So in this case, there are GCFs. So I feel like when you get to here, you're like, wait a second. binomials don't cancel perfectly fine. The only thing I do notice can happen is I can reduce this fraction, right? 6/3 could reduce to just be 2. So you would write that 2 in the numerator, because it would be 2/1. I guess you don't really do that in parentheses. And that would be your final answer. So simplify just means if you can, great. Sometimes you'll get to there and you can't do anything, and that's also great. You just kind of leave it. You do have to put domain restrictions. In this case, a could not equal 4. So I just do it based off the factor form. It's a little bit easier. So I'm gonna have you guys try 3. So to the best of your ability, can you keep that common denominator, add the ones in the numerator, and then just see, can you simplify? Well, I took my attendance, or I took half of my attendance. Let me just finish this up so I don't forget about it. You guys are gonna try that one. Flux. Oh, goodness gracious, I can't remember who was here in my last class. All right, so let's look at that and just see, like, if we tried a few, could you kind of follow along? Main goal being combining, either adding or subtracting. In this case, we're adding first, and then after that, could you simplify it all? So number 3, 2x squared minus 55. X squared plus 7x. Okay, so I notice common denominator, I'm feeling good about that. Unfortunately, that step's gonna end soon. So we're gonna start to get uncommon denominators. Okay, so I'm just gonna kind of add as I go. So 2x squared plus, that's negative x squared. That would be just x squared, right? Okay. Negative 55 plus 6 would give me minus 49. All right. At this point, I'm saying, is there anything I can do to simplify, aka can I factor? And I can. X plus 7, x minus 7. On the bottom, there's a common denominator. And then is there anything I can cancel or reduce? Yes, I can. Your final answer should be x minus 7 over x. Remember, these cannot just cancel out. This is technically a binomial. You don't need to put parentheses if there's just one. It's not attached to anything, but it would stay like that. X could not equal, think about your factor form. There's an x here, so that one can't equal 0. And then if I set that not equal to 0, that would be negative 7. So as a heads up there. But you guys were trying that one. As you were trying it, was there any specific part of that people have questions on? Okay, I'm gonna go with no. All right, so we're just gonna kind of keep moving forward. I think the next one, there's one more with a common denominator, and then they start to get a little bit more exciting. Well, not really that much more exciting. Actually, I'm gonna skip 4 for now. I'm gonna skip around a little bit because my last class we only got like 8 problems done, and I wanted to get more done. So we can go back and do 4 in a few minutes. 5 and 6 are kind of similar, where you're looking and you're saying, well, that doesn't look that bad. There's just numbers in the denominator. I know how to do that. So 5 is exactly that. Kind of like our warm-up. Nothing too exciting. no variables, no binomials or trinomials. So we go to some variables. But we would find a common denominator. In this case, it would just be 24. So this looks very similar to what we did in that warm up, because that stuff does pop up, so I wanted you to see it. If I change the denominator, I need to change the numerator. So this one I multiply by 2, so I'll do the top with it, or do the same with the numerator. This one I multiply by 3, so same with the numerator. And this one I multiply by 4. Set them exit. All right, then we're just kind of really combining my terms in the numerator. The denominator is common, so it stays the same. 14 plus 9 is 23. Minus 20 is 3x. It's working in slow motion today. And then once it's combined, you're just saying, can I factor? No, I can't factor that, but I can reduce it. It's just like a regular old fraction here. Because 3 over 24 will reduce to 1x over 8. Or you can just write x over 8. This is a problem. I feel like every problem we've had has had a domain restriction. This is the problem that does not have a domain restriction, because there are no variables in the denominator. So that's what a problem with no domain restriction looks like. No variables in the denominator. Okay, so let's look at 6, and then we'll kind of do some ones where maybe there's binomials or trinomials even that don't have common factors, and like, what the heck do we learn? So let's look at number 6. The number ones aren't bad. All right, let me just write it out here. Okay, so first step, common denominator. Okay, that step shouldn't be too bad. In this case, it would be 50. If I change the denominator, I need to change the numerator. I multiply this by 5. I need to multiply the entire numerator by 5. So since it is a binomial, you need to multiply both terms. I do suggest just distributing it in, because we're going to have to combine it with some stuff later anyways. So I'm just going to distribute it from right here, and that would be 15n plus 45. This would be multiplied by 2, so this entire binomial gets multiplied by 2, and that would give me 4n minus 2. This got multiplied by 10, so you know the deal. That gets multiplied by 10, and I'd be left with 10n minus 8. Just be careful with the subtraction. I usually just kind of distribute it up, and that would become minus 4n plus 2, and now we can combine everything. So 15n. Oh my God, why did I do that? That would be 80. Thank you. Yeah, tell me. If I'd make it to break at this point without my brain exploding, it might be a miracle. Okay, 15n minus 4n is 11n. Plus 10n is 21n. We got 45. Remember, it's now plus 2 because you had a double negative. So that would give me 47. Minus 80. What's 47 minus 80? Negative, what is it?
33.
Negative what?
33.
Yeah, sorry. In my mind, it was not that, but you're totally right. This was problem last period as well. I'm just struggling. Okay, so we get here and we say, all right, is there anything else I can do? I see the top is factorable. There's a GCF of 3. So I have my 3. I'll be left with 7n minus 11 over 50. But once I do that, there's really, it doesn't really help me. But you do always want to check and factor if you can. So we would just leave our answer like that in factor form. And once again, there would be no domain restrictions because nowhere in that problem are there variables in the denominator. So just as a heads up there. Okay, so we've seen common denominator. We've seen denominators, maybe where we had to change them, but they were just numbers, so nothing really too fancy was going on. But now we're gonna start to look at maybe finding common denominators when we have polynomials. How exciting. So let's look at 7. Too much talking. So those definitely are not the same. So my first question is, can I make them the same? And I can pretty easily, right? If I just multiply this entire binomial times 2, it would equal that. So that's my main goal, make them the same denominator. So I'm gonna rewrite both fractions with the denominator 6x plus 24. Because since I multiplied that denominator by 2 to make those match, I'm gonna multiply the numerator by 2. Common denominator stays the same. Add the numerators. Is there anything else I can do? Yeah, that bottom is factorable, right? There's a GCF. X plus 4. And I can reduce it because 9 over 6 reduces. So that would give me 3x over 2 times x plus 4 is my final. And my domain restriction is x cannot equal, I always go off the factored one, it just makes it easier to solve it. X cannot equal -4. All right, so that one, we have to do a little bit, but it wasn't as bad. Because you could just kind of take one binomial and multiply it by a quick integer. But number 8 is going to be a little different because you can't do that process. So this is where the fun part comes in. All right, wait a second, I need a sip of water. Talking too much. Okie doke. So I look and I say, all right, I have 2 binomials, how exciting, whoa. But unlike number 7, where I can just kind of multiply one to make them match, that's definitely not happening here. I can't just multiply this to make it into that. So I'm saying, oh crap. What the heck do I do? So what you are going to do, the numerators are going to stay the same. Even if you can do something, just keep them. So we're not touching the numerators. But what we are going to do is factor the denominators if possible. And in this case, we have a common, or not a common denominator, we have a common factor of 2. So that goes y minus 3. And then here we have a GCF of 5. Okay. So now we need a common denominator. So we're thinking, okay, well, what the heck is that going to be? So you want to do this in steps, just kind of seeing what you're multiplying to get your denominators here. So I'm going to start with these numbers out in front first. If I had a 2 and a 5, what would the common denominator be? 10, right? I didn't tell you to yell it out, but thank you to the person that did. So, okay, so you kind of just take it in like little sections here. Now look at it. They both have a y minus 3. So if they have it in common, y minus 3 has to be in your common denominator. So your common denominator is 10 times y minus 3. Okay, so we found the denominator. We had to do a little bit of work to find it. Now we need to change our numerators. So they have the y minus 3 already, so we're all set there. But this went from 2 to 10, which means I multiplied this by 5. If I multiply that in, that will give me 15y minus 25. I'm going to kind of think about the same thing in the second fraction. All right, I got the y minus 3, so I'm good. But I went from 5 to 10, so I multiplied it by 2. So I need to multiply this whole thing by 2. Okay. So now I'm just going to try to combine. So I'm just keeping my, the denominator is just kind of moving across. I'm now going to combine my numerators by subtraction, so be careful. You can either kind of distribute this. That becomes negative 8y plus 4, or just remind yourself that you're subtracting. And what do we get? 15 minus 8 is 7y. Negative 25 plus 4, because remember we're subtracting a negative, is negative 21. Okay, so it's looking pretty good. Can we simplify it? I have no clue, so let's try to factor the top. And it has showed me that yes, I can simplify because we have common factors. My final answer is just 7/10. What a beauty. There is a domain restriction. I'm just looking at the factor form, and x could not equal 3. Just does that restriction. Oh my goodness. So some of these were same. Once again, the numbers aren't bad. You're just doing like multiplication, little things. It's finding the common denominator and then just staying organized after that step. And so all steps we've kind of gone over. I'm just going to give you a second. I feel like sometimes I just get so into it, I rush through it. So I'll give you a second if you're catching up. I'll remind you of that in a second. All right. As you can see, some of them take a little more work. I'm sorry. Because there's a lot of problems on here, but then usually I space it. My life has been a little bit busy, so I'm doing my best. If you need to ever do something on a separate sheet of paper, feel free, just to give yourself a little extra room. I know some of these take a little bit of work. So let's look at 9. I'm going to have you guys try 10, and then we'll probably wrap it up. I think we're pretty much going to be out of time. We're not going to get to every problem on here, and that's okay. We might do a few on here tomorrow, just depending on our common denominator stuff. But whatever we don't finish, I'll just make an answer key to this, and if you need extras as you're studying, or you just want to try a few more just to feel comfortable, I'll just throw it up on our Google Classroom if you like it as a resource. But I'm not checking this. But just as a heads up, it will be there. So let's look at 9, and then we'll see how much time we have. Okay, I looked, I need to add, no common denominator, I need to find one. In order to do so, I'm going to factor my denominators. So when I factor this first one, good old difference in 2 squares. Over here I can't do anything, okay, so that's just that. So I now need to make 2 new fractions with a common denominator. So think about what a common denominator is. They need to have it in common. So see how they have x plus 2 in common. That means x plus 2 is going to be in my common denominator. There we go. Okay, so as I'm making these new ones, x plus 2 is in. Now this one has x minus 2, and this one does not. So this x minus 2 has to be in my common denominator. If it's a part of anything, it has to be over here. So if it's a part of one, it has to be a part of the common one. But the issue is, this didn't have it. So just like over here, when I went from 5 to 10 and I multiplied by 2, if x minus 2 is in the common denominator but it's not here, that means I have to multiply it by x minus 2. So basically, if we are taking something from here and putting it in the common denominator, if it's not there, you have to multiply it by it. So the first fraction stays the same because that is my common denominator. But the second fraction had to get to multiply by x minus 2. So I'm going to distribute that in to that numerator. I can now write one fraction with my common denominator and combine those numerators. 2x plus 4x is 6x minus 2. GCF in the top, right, of 2?
Wouldn't it be -8 instead of 4 because 1 is 2?
Oh my God, what did I do? Oh my God, what is wrong with me? Yes, sorry. 4x minus 8. Golly, I knew I did something wrong when I got to there. I'm sorry, I'm a mess today. So that would be 6x minus 8. Okay. No, that's not actually. That much more. But, so you still have a GCF of 2. You'll be left with 3x minus 4. X plus 2x minus 2. Okay, that's perfectly fine. Nothing cancels, so that's just my answer. But you do need to factor everything out to make sure there's nothing else you can do. There are domain restrictions. X cannot equal 2 or -2. And that's about all you can do from there. Yeah. So this is the section we're gonna work on a lot tomorrow. Like we have a bunch of binomials. How do you find the common denominator, and then how do you maybe change those numerators based on that? The main goal is, if it's in the denominator, it has to be in the common denominator. So if it's not included in 1, you just have to multiply it by it. Sorry, as I'm like on this camera.